So you've often been mistaken and quoted out of context about maybe Moore's law uh, dying or slowing down, and it was a popular thing that it ended at 28 nanometer. But you've blown well past 28 nanometer. Uh, Let me put it in your words. What do you really believe about Moore's law?
Well, although some articles maybe don't get it quite right, my belief, Intel's belief, is that Moore's law is still alive and well, at least at Intel.
So when we think about it, there's a lot of also mistaken stuff about what Moore's law really is. At the end of the day, if you read his paper, it was originally about density. Now, as we've gone from planar to fins, what does that really change the density equation, or does it just change how we used to measure a node versus how we measure it today?
Well, we have changed how we measure density. And in the past, maybe all we focused on was gate pitch, transistor gate pitch. But now I think the right metric to really estimate logic density is a product of gate pitch and logic cell height. So that's what we use now to judge our technologies and their density.
And at the end of the day, when you map what you're doing against what everyone else is doing, you can really see exactly where everyone's density is. And you can also see what you like to call, you have a true 10 nanometer versus opposed to some of the other marketing 10 nanometers, and density really shows the difference ultimately, right?
Well, everybody seems to be using about the same node names these days, whether it's 14 nanometers or 10 nanometers or maybe even 7 nanometers. But when you look under the hood, so to speak, and you look at some of the dimensions for gate pitch and cell height logic cell height, I think that you recognize that not all 10 nanometer technologies are the same. Intel has a true 10 nanometer technology delivering the expected density improvement.